You know that long, intimidating string of numbers and letters for your crypto address, like 0x0b something something?
Oh, yeah. Always makes you double check, doesn't it?
Triple check. But what if it could just be, say, your name.f? That's the promise, really, of the Ethereum name service, ENS.
And it's so much more than just a nickname, right? People sometimes miss that.
Exactly. It's way more. So today, our mission is a deep dive into ENS. We want to unpack its architecture, understand how it's really laying groundwork for digital identity in Web3.
How it simplifies things.
Yeah, simplifies interactions and even bridges over to, the regular Web2 domains we all use. There are some genuinely surprising bits of tech in there.
Definitely some clever engineering.
Okay, so let's get into it. At its heart, ENS isn't just like one single contract. It's more of a system. Three main smart contract pillars working together.
Right. Modular.
First up is the registry. You can think of this as the bedrock, maybe.
Right.
The central phone book for all ENS names.
The source of truth.
Exactly. It maps a unique identifier. They call it a node. It's basically a hash of the name to three really crucial things.
Okay, what are those?
Who owns the name, which contract actually handles resolving its data.
Right.
We'll get to resolvers. And how long clients should cache that info.
Right, the TTL. Time to live.
Yeah. And the really profound part, the ENS DAO, the Decentralized Autonomous Organization, actually controls the ultimate root of this whole system.
Which is huge for decentralization. It's
Yeah.
not one company in charge.
Precisely.
Yeah.
Okay, pillar number 2, registrars. If the registry is the phone book, registrars are kind of the gatekeepers. They set the rules for getting names under specific top-level domains, like the big one, .f.
Okay, so how does the .eth registrar work? I know it's a bit special.
It is. It's this really clever two-contract setup. One contract, the base registrar, just handles the ownership. It mints your .eth name as an NFT, an ERC 721 token.
So you truly own it, like digital property, tradable, transferable.
Exactly. Then there's another contract, the ETH registrar controller. This one handles the actual registration logic, the pricing, the commit reveal process to stop front running.
The mechanism to prevent bots from sniping names.
Right. And this separation is smart because the DAO can update pricing or registration rules via the controller without ever touching the base registrar, without affecting your actual ownership NFT.
That protects the property rights.
Very important.
Totally. Then the third pillar, and this is where it gets really flexible, resolvers.
This is where the data lives, right?
You got it.
Yeah.
If the registry says who owns your name.f and the registrar says how you got it, the resolver answers, okay, what does your name.f actually do?
Like, where does it point?
Yeah, it holds the actual records.
Yeah.
Your Ethereum address is the obvious one, but also maybe a link to your decentralized website, your IPFS content hash, even your Twitter handle or email.
So you can consolidate a lot of info under one name.
You can. There's a standard public resolver most people use, but the key thing is anyone can write and deploy a custom resolver, which makes it incredibly extensible. You could point an ENS name to almost anything if you code the resolver for it.
Exactly. Future-proof.
It really is fascinating how these pieces fit together to solve some tricky problems like name processing.
Right, because myname.eth and myname.ith should be the same thing.
Precisely. Before anything even hits the blockchain, the name goes through normalization using ENSP15. It standardizes it, usually to lowercase, preventing spoofing with lookalike characters.
Oh, I say, crucial for security.
Definitely. Then it computes the name hash. This isn't just a simple hash, it's recursive. It turns sub.yourname.if into a unique fixed-size ID that's efficient for the blockchain to work with.
Got it. So normalization first, then name hashing.
Yep. And another area with clever security is reverse resolution, going from the address back to the name.
The primary name feature. So 0x can show up as nick.eth in my wallet.
Exactly. But here's the safety mechanism. To prevent someone setting their reverse record to, say, vitalik.eth fraudulently, your wallet must do a check both ways.
How does that work?
If your wallet sees 0x123, claims to be nick.eth, it then immediately checks, does nick.eth resolve back to 0x123?
A round trip.
Right. If that second check fails, the wallet should just display the raw 0x address. It puts the verification burden on the client side.
That's smart, very user protective. But what about costs? Storing all this on Ethereum L1 sounds expensive.
It would be.
Yeah.
And that's where scalability via CCIP read comes in, EIP 3668.
CCIP read. What's the gist?
The gist is, a resolver on L1 doesn't have to store the data itself. It can basically tell the application querying it, hey, the answer isn't here directly, Go fetch it from this other place.
Like an off-chain gateway? Or even a layer 2?
Exactly. Fetch it from, say, a server or a layer 2 like Linea. Bring the data and a cryptographic proof back to me and I'll verify it.
Okay, so the main chain just verifies the proof, not stores all the data.
Right. It allows for cheap subdomains managed on L2s, or even data from centralized sources like Coinbase's cv.id, but still anchored securely to the L1 ENS name. It's super pragmatic.
That makes a lot of sense for keeping costs down. What about connecting to the old web?
Yeah, the DNS integration, this is also huge. You can actually use your existing .com or .org domain name within ENS.
Wait, really? How does that work without, transferring your domain?
It uses DNS SEC, which is a security extension for regular DNS. You basically add a special text record to your DNS settings.
Okay.
ENS contracts can then read that DNS record, verify its cryptographic signature using DNS SEC, and boom, you've proven on-chain that you own that Web2 domain.
Wow.
And there's even a gasless way to do the verification part, again, using CCIP read. It shifts the cost of checking the DNS SEC proof from the blockchain to the person looking up the name.
Making it almost free to link your traditional domain. That's incredible.
It really bridges the two worlds.
So pulling this all together for, the user, what's the bottom line? There's an economic model, right?
There is. For .deb names, it's designed to be sustainable and discourage squatting on valuable names. You pay an annual rent.
How much are we talking?
It's length-based.
Yeah.
5 characters or more, just to $5 a year currently. 4 characters are $160 a year, and 3 are $640 a year.
Okay, so steeper for the shorter or rarer names. Makes sense. And where does that money go?
Straight into the ENS DAO treasury. Doesn't go to any company. The community, the holders of the ENS governance token, decide how to use those funds for development, public goods, whatever they vote on.
So it's truly a community-governed protocol. The users own and operate it.
That's the core principle. A decentralized public good.
We've really seen then how ENS is this incredibly modular, really extensible and community-run system built to simplify things, unify your identity across Web3 and even Web2. It's becoming pretty foundational.
It absolutely is. And it leads to a really interesting question to think about. As our lives online blend more and more, our on-chain activities, our off-chain stuff, and with all these layer 2s popping up providing scale, what new kinds of digital identity might a system like ENS enable? Things we maybe haven't even conceived of yet.
Dynamic identity across different layers and contexts, all anchored to one name.
Exactly. Something for you to mull over until our next deep dive.